Welcome, ladies and gentlemen, back to Chapter 18, dealing with covalent bonding today. This is the first part. If you remember yesterday, we talked about why things bond. Today we're going to talk about how things bond. Okay, first off, you should remember that covalent bonding is when electrons are shared between two atoms, and you saw the description as well as an image. Okay, today we're going to start by showing chemical bonding, which is covalent with fluorine. Okay, first off, you look at your periodic chart and you notice up in group 7A, that means there are 7 valence electrons. With bonding, we only care about the valence electrons. We don't care about all of the others. So you don't need to worry about Bohr models. You just need to worry about the valence electrons, the ones in that outer level. Okay, so when you are doing this, you first start out with your nucleus. You don't need to worry about how many protons or neutrons, just draw the nucleus. Then, once you've determined how many valence electrons there are, in the case of fluorine there are 7, you draw your ring and put your 7 electrons around it. Now, when doing this, I strongly recommend pencil, because you are going to need to erase and move things and rearrange things, and you don't want to try to be doing this with pen. Okay, so this is a single fluorine atom. Now obviously to bond it, it has to have another atom to go with it. Now fluorine actually naturally appears as the molecule F2. So fluorine can bond with another fluorine. So after you draw your one fluorine, you're going to want to have another one. Now, what you'll notice and remember is that when we look at the valence level having 7, that means it's actually quite reactive because it wants one more valence electron. Okay? Both of these fluorines want one more in order to have their level filled so that they're stable. And what happens is all you need to do is move them together, and they actually can share 2 of the electrons. So if you look at one fluorine and you count around, you go 1, 2, 3, 4, 5, 6, 7, 8 electrons for that fluorine. And looking at the other fluorine, you go 1, 2, 3, 4, 5, 6, 7, 8 for that fluorine. So it is stable, and that right there is the covalent bond. They are sharing those 2 electrons, and you have to draw it that way so that both of these electrons are touching both fluorines. Otherwise, they are not sharing it. Now, in real life, you don't have these cute little rings and things like this, but this is the process of what happens. Okay? So you can visualize it. You have atoms moving around, and when they bond like that, remember they're reactive, so that energy is given off, and they become a stable F2 molecule, which will just float around in the atmosphere. Okay? So they become very stable once they have shared those electrons. And this would be the scenario where they have equal electronegativity. Remember, that's the attraction for the electrons. So neither can pull the electron away from the other. They are both strong, they are both pulling, they keep those electrons. Okay, next, to get a little more complicated, you are going to make water. Okay, so you look at your periodic chart and you find oxygen and hydrogen, which are the two elements of water, and you notice that oxygen has 6A, which means it has 6 valence electrons, and hydrogen is in group 1A, which means that it has 1 valence electron. So, now, one of the hints, if you usually have multiple of something, like in this case hydrogen, and a single of something, in this case oxygen, generally start with the oxygen. Okay, so you draw your nucleus, put your ring around it, and in this case you have the 6 valence electrons. Now, for hydrogen, you draw the nucleus, and it's going to have only 1 electron around it. Remember, hydrogen will be content once it has 2. It is in that first level. So hydrogen only needs 1 more. Oxygen, if you look at it, will need 2 more. Now, this little 2 right there means, remember, that there are 2 hydrogens. So you're going to need to make the scenario where you have 2 more, or 1 more, so you have a total of 2. Okay, so these are the parts you're going to be playing with. 1 oxygen that needs 2 electrons, and 2 hydrogens which each need 1 more. So, like I said, start with oxygen in the middle. Okay, and please use pencils. If you have an erasable pen, you can get away with it, but even that starts to look messy. Now, you have 1 hydrogen, and then you have your other hydrogen. Now, the hydrogen, this electron right here, will need to be shared to the oxygen because the oxygen needs more electrons, and the hydrogen needs another electron. So, what you do is you come and you look and you say, okay, this one needs more. That electron right there is not paired with another electron. So you actually can move the hydrogen over and have both of these electrons right here be shared both by the oxygen and by the hydrogen. Now the hydrogen, if you look at it, is stable. It has 2 electrons in its outer level. However, the oxygen at this point doesn't have enough. It still has only 7. That is why we can take the other oxygen and we'll be able to bond it. And the covalent bond in this scenario is right here. These 2 shared electrons between the hydrogen and oxygen. So since oxygen needs 1 more, hydrogen goes over, and you now have it balanced and stable. So this hydrogen has 2 electrons in its outer level. This hydrogen has 2 electrons in its outer level. And if you look at oxygen, oxygen has a full 8. So this is a stable molecule. It is no longer reactive. Okay, you're going to have some practice problems on how to do some of the simpler covalent bonding. You're going to need your periodic chart unless for some reason you have it memorized. So I will talk to you next time and give you some more complicated covalent molecules. But don't worry, you'll be able to do it just fine.